puts the man in the farmer's fleece back to show you how not to do an engineering schematic. I think I've already noticed some issues here. No, I haven't. Okay, let's get into it. So, compared to last time I showed you the power schematic here for this tempeh maker that I want to do, and I will do it. So I've got all that. I still had to connect these. I think I'm missing that one actually. No, I did. Okay, good. So, programming header, main microcontroller STM32 based. This one has Bluetooth capabilities, and I say how not to do it because I'm still learning, and I don't want any of you to pick up bad habits. So whilst I'm going through here, and you can see all this thing here. I don't know if that makes a difference, but anyway, programming header. I've put in some I/O switches. I've got an RGB LED here, and this, I don't know if I'm going to use them, but it's nice to have anyway, just in case I want to put a push button. I've got the voltage programming pins go here. Everything, all the power decoupling capacitors required, the ground were required, except this one, which I need to add if it wants to. Nice. Got the I2C comms here. I'm going to try and connect it to a OLED display, and I've never done that before, but it's going to be interesting. See if I can do that. The main crystal here, no, that's the RF crystal or what. But what I want to get across is, this is the main schematic that I've done here, antenna. And to find this out for this schematic that I've got here, you would reference the datasheet. I didn't know this when starting out. I always thought like, oh, how do people like decide what decoupling capacitors to use? How do they know which crystals to use? It never occurred to me that read the datasheet. Of course, the datasheet did not even exist to me back then. Didn't even know what a datasheet was, and now that I do, it's like the holy grail document for whatever component or part you're choosing. So the datasheet will always have a nice I don't say always. I've found some that don't have it, but it's quite rare. They will have your pinout, what you need to connect to, what does your pin functions do. Very helpful stuff. And if we just take RF as an example, so RF subsystem, you can see that it's told us what parts we should use. The antenna, some reference for the crystal recommended, and as you can see, for further details, refer to AN5165, so application note. Very helpful stuff, and I do recommend reading that when you're starting out a project. It will cover up most of the things to get your microchip or whatever part working. So the power supply scheme here, this is one I used in connecting all the capacitors up and everything was required. Let's see, I've done that here. So this is what you would always want to do, refer to your data sheet. It seems like such an obvious thing, but you know, I would imagine if I didn't do it, then many other people starting out wouldn't have realized. They would think, you know, you see so much information, it's all about analog and everything. Whilst there is some really good information, brilliant YouTubers that do give you so much good, high quality information, but it's looking for them. I feel that's a bit of a hard one to do if you don't know what you're looking for. And especially when you like searching engineering tutorials or like building circuits, always like analog, and well, it's not a bad thing, but I suppose that many of you would want to have a go with digital design with microcontrollers, like embedded programming, things like that. It's not always a bad thing. So I've got the battery voltage reader here, 12.6 going in. It's the max battery voltage charging. I'm going to step that down to 3.3 volts, simple voltage divider. Antenna, as I said before, all necessary connections. That should be pull-up. See, I've realized my mistake. So with I2C, you need to have a pull-up resistor. So let's see if I can do this. So with I2C, you need a pull-up resistor, not once connected to ground, and you do that on the voltage that you're working with. I have some test points for debugging purposes, because there will be errors. I guarantee you now, with every single project there will be errors, and you're going to be thankful that you put test points so you can test your circuit. From here, I think the next part of the project is to put in all the connectors that require. Put in the temperature sensor. So I have selected the temperature sensor SHT30, which I do need to make another schematic for, which I will do. Won't be that hard. All the other connectors that may be necessary, like I said, and I think it just become to PCB layout after that. Still, I put the OLED display and whatever. It should be quite good. Should be quite good, but it's near the end, and I can't wait to do the PCB layout. Oh, one last thing about this antenna here. These antennas are Bluetooth antennas, so it's a 2.4 gigahertz. Usually the antenna might give you a reference circuit as well to what the filter or impedance matching circuit would be. So this is just given from the antenna itself. So not to worry about that. Of course, you can solve it out yourself if you really wanted to. There's also a better way to do this if you separate it out to make it more neater if you really wanted to. So what I could have done is separate this out into 3 parts or something. So I'd have the RF part, I would have the general GPIO part, and have the voltage, the input supply voltage. So you'd have like input supply or decoupling caps, general GPIO, RF stuff down here, programmer cable. It depends how you like to do it, but as you can see, this could be a bit of a cluster if you're not too used to looking at these things. It can be a bit messy. It does look a bit messy, but since there's not that much on, I feel it was alright for now.